can't find out what they did until they listen to the video. Okay, after class I'll send it to a YouTube video, but the thing is, if they're not here, they don't know to go to a YouTube video to do it. So it's kind of a catch-22, but I will put something out there on Blackboard telling them to go there. Okay, probably do an announcement just like you had for today. All right, so this has me a total of 17 students. Let's see if I can go back to Blackboard again and see if it's 17. Yeah, no, 16 students plus me is 17. Okay, so evidently Janiyah had to get off to, oh, I can't find, there we go. Okay, so Janiyah's not back yet. Okay, so we got 16 students here. Good to see all of you. Okay, I may not see you again, but good to see you at least this time. Okay, now I'm going to pull up one more thing. In fact, I already got it up. I'll come back to this if anyone else comes in the classroom, and that's going to be this. Okay, so now, I know this is a sort of a specialty course. Are any of you brand new to Lawson State? Or all of you existing students, you've been here before? New, okay. All right, well then let me go over our Blackboard. At the schools where you were before, did they use Blackboard? Yes. Was it Blackboard Ultra or the old Blackboard Learn? You think it was Ultra? The old one. Okay. So let me go over this. Now, it's not filled out, as most of you realize, because those who have looked at it, you know it's not done. What I'm going to do is share my screen here and pull up Blackboard if I can find it. I think there it is. Okay. Okay, can y'all see my Blackboard homepage? Okay, good deal. All right, now you can't see what I'm doing now. I'm moving a toolbar, taskbar out of the way, and then I got to scoot Jimmy over because he's in the way too. No, I'm just kidding. Okay, got your pictures out of the way. Now, if you see somebody else trying to come into class, let me know. Now, this is Blackboard Ultra. Okay, this first thing you see here is a template user, and it says it's for, I got to move y'all out of the way again. Okay, it says it's for faculty. So I'm not going to open that because you're not faculty. Okay, in Blackboard Ultra, you see this icon right here. That's the course content. That's where we are. This is what course content looks like. That's why the name is here. Let me go over these others. This one is a calendar. I don't ever use a calendar. Dr. McBool may, so I'll leave that up to him. This one says discussions. If you send it to me, you can, okay? No, okay, your microphone's on, by the way. Okay. Wait a minute. Okay, I like your choice. I don't know who's doing the talking, but your microphone's on. And I just got your order, but I can't send you anything because I'm on a diet. Okay, never mind. That's why I was anxious for you to send it my way. Okay, I'm just sort of kidding about most. This next icon over here is discussions. Okay, I'm not going to use discussions unless you want to use discuss. Okay, I think someone has a microphone on. I don't know who it is.
I think it's Amber.
Amber. Yeah. Okay, Amber, can you mute? Let's see, I can do it. Okay, I just muted her. Okay, did that do it? Yes. Okay. All right. That's your discussions. Now, when I teach a class, I say, if you have any question that you want to talk about as a group, as a class, let me know. We'll put it on the discussion board. And last term, I taught 7 or 8 classes, and nobody ever wanted to do something on discussion. So that's mostly for online classes, not the virtual classes. But if you want to do it, then talk with Dr. McBool. He's maybe willing to do it. Here's the grade book. Okay, there's nothing out there now, obviously, but that's where that will be. Here is Blackboard Messages. This is where you can send messages to me or to one another, and you can send things that Dr. McBool, if he assigns something and you want to send it that way, he can do it that way. This last icon over here is Analytics. I've never used that. I bet you it's pretty interesting, but I don't usually mess with it. So there's your icons at the top. That takes you to the different places that you need to be. So let's go down here under Content, and it says Start Here. Now I'll tell you, there's nothing here, okay? But what will be here when he gets into it is, okay, here's somebody ordering something else. Is that Chelsea? Okay, I'm going to mute you too. All right, if you want to come off, just unmute yourself. Okay, here's navigating the course and online learning tips. Guess what? That's mostly for online courses. Maybe some of that will be beneficial for you. I'll let Dr. McBool decide whether he's going to keep that or not. Here is where the course syllabus will go. It's not there now because Dr. McBool hasn't modified it yet, and he'll probably modify it and put it out there. What I'll do right now is show you the course syllabus that I used last spring, I think it was, when we last taught the course. Now we may have been using Ultra then, so I'm going to pull that up. This will be the syllabus, if I can find it. Okay, I don't see the syllabus. I pulled it up a bit ago. Let me pull it up again. Okay, get out of this. Okay, I don't know why it's still not there because I pulled it up a bit. Okay, there it is. Let me now get it onto screen share. There it is. All right, now this is the syllabus I used last spring, the last time I taught this course. I had several terms in a row that we had made every time, but then last summer it didn't make. Okay? No, I'm sorry, it did make last summer. So this is last summer's syllabus because we met Tuesday, Thursday afternoon, 5 to 6:30. You're going to meet Wednesday only, 4:30 to 6:30. Okay? Your instructor will change. It'll be Mohammed McDoul. Okay? He doesn't have an office on either campus, but he'll probably give you an office phone number or maybe a cell number, whatever he wants to do. And once he gets on board, he will give you his Lawson State email, or he may give you his UAB email. I don't know. That's my Lawson State email, so you can email me anytime you want to. Okay? Now, office hours. This was mine for last summer. It doesn't pertain now because I'm not going to be here, okay? So forget about this, but Dr. McBool will put his office hours. My guess is he'll put them on Wednesdays. Maybe before or after class. He may put some on Monday or Tuesday or Thursday. I don't know. That's up to him. Now the rest of this is going to be fixed. You'll see this when he does the course or me. This was done by the state. This course introduces the student to the basic principles of physics with an emphasis on electricity and magnetism. Why? Because y'all are getting into, I hope you're getting into, the diagnostic medical sonography. Yes or no? Okay, good deal. If any of you are not going into that program, this course is probably not the one for you. Okay? It doesn't count as a science for anybody except the diagnostic medical sonography students. So if that's not you, you probably need to find a different course. Okay? It's designed to provide the student with not only a basic knowledge of electricity and magnetism, but also an understanding of real-world applications. To prepare the student to understand electricity and magnetism, additional topics include, now get this, forces, work, energy, and by the way, work and energy are two sides of the same coin. Power is very closely related to those two. Sound, well, certainly if you're going into sonography, you need to know about sound. And the atomic nature of matter. Okay, now the reason I'm harping on that, the next thing I'm going to do is show you the text. Okay, and I'll show you which chapters we're going to be covering. The topics in electricity and magnetism include electrical forces and fields, catch that, currents, catch that, electrical circuits, got that one, magnetic forces and fields, capacitance, electromagnetic induction, and transformers. Okay, those are the topics we'll be hitting. You'll be hitting. Okay, here is the text. The author of it, and it is required, but whether it's a book copy like this one, or if you can find a ebook or PDF book, anything you can find, if you can find it, get the book. And here it is. It's Applied Physics. I'm reading it backwards so I can't say 11th edition, and the authors are down here at the bottom: Dale Ewan, Neil Schurter, and P. Eric Gunderson. Okay, now this book is published by McGraw-Hill. No, I'm sorry, not McGraw-Hill, Pearson. I know a lot of the books here at the college are Cengage, and if you were in a Cengage book, if you paid for that Cengage Unlimited one time, $119, then you're good for all the books you needed. However, now there's a little bit of history here. This diagnostic medical sonography is a fairly new course in the two-year college system, Alabama two-year college system. It was started, I think, at Wallace-Huntsville, or one of those Wallace campuses somewhere in the state. And since they started it, they chose the book. Okay, and frankly, it's not easy to find a book that covers things at the level you need it. So you have to you're sort of stuck with this. And the reason I say stuck, it's a Pearson book, not a Cengage book, so you don't get to use Cengage Unlimited. But number two, in my understanding, I didn't have to buy the book, they provided it for me. It's an expensive book. So that's why I said if you can go out there and find it cheap online, a used book, a ebook, or anything such as that, find it. But if not, if you got Pell Grant or something, it's going to cover the cost of the book. So get the book. You'll really need it, I think. Yes.
Do you mind if I say something?
Say something.
The book you can actually get on for Chegg. You can rent off the Chegg for really cheap.
Yes.
Semesters. So if y'all want to take Chegg, that's where I get all my books from.
Right.
They're cheaper to rent, or some of them you do have to buy, but you should be able to rent it for cheap.
Right. Have you rented this book for this course yet, or are you going to?
Yes, sir.
Okay, so you were able to rent it. Okay, excellent. I was going to bring that up as another option, but I'm glad you did. Now, Chegg is spelled C-H-E-Q or something like that?
No, it's C-H-E-D-D.
Oh, Chedd. Okay, C-H-E-D-D. Okay, I'd always heard people say it, but I never had seen it spelled, so I'm glad you said that. So you can get it, rent the book. You're only going to need it this one term. You're not got another class from it, so rent it from them for the whole term. That's going to be a very good way to go. Okay, how fast is the turnaround? Yes,
Also rent it from Amazon.
exactly.
Mine for like $42, something like that,
Okay.
on Amazon.
Yeah, my wife does lots of things through Amazon, so I know that's a good source. And guess what? For those of you who don't know, Amazon started as a book, an online bookstore. So they certainly have books. Now they do everything in the world, but they started as a bookstore. Sadie, how much was the check? Do you remember?
I can't remember.
Okay, but good prices, very good prices. If you buy the book new, I think it's probably in the $200 range. 22, 42, something like that sounds a whole lot better to me. I'm cheap. Okay. So there's the book. Um, and that's listed here. But I wanted to show you what the book looks like too. Picture I think the Golden Gate Bridge there. Okay. Um, and students, you are expected to bring or when I taught the course, I expect you to have a book. Okay. Ebook, I don't care, because I teach from the book. I figure if you have to buy it, I'm going to use it. Okay. And we'll be doing lots of problems from the book. Now, if Dr. Makbul does a different way, then I'll apologize because I'm telling you wrong. But I say also bring paper, pencil. Okay, calculators are permitted. In fact, I would say encouraged. We'll be dealing a lot of big numbers that you use scientific notation. If you don't know how to do that on the calculator, if I were teaching it, I'll walk you through it. Dr. Makbul probably will do the same or help each other out. Okay. Blackboard. Now, I don't like this sentence here, so I'm not going to spend too much time on it, but it says all courses must use Blackboard to gain access to vital course information such as the syllabus, handouts, PowerPoint shows, activities, assignments, announcements. I don't know what Dr. McBrule put on Blackboard. There's nothing there now, but it says failure to use Blackboard will severely damage your ability to pass the course. To me, that is a ridiculous statement because it's so negative. I would say the proper use of Blackboard could greatly enhance your ability to do well in the course. That to me is a lot more positive. It says students should always check the Blackboard announcements and task pages prior to coming to class. This was back when we were on campus, okay? Or this was when it was written. So there is a new paragraph they'll have here about virtual classes. Basically, it's there too. So I'll just leave it like that. So here are the professional competencies and student learning outcomes, course student learning outcomes, if I can get my thing to scroll down. Students will solve problems dealing with forces. Remember, that was one of the topics that you have to do in order to understand electricity and magnetism. Students will solve problems dealing with work and energy. Now, the reason I scroll down here, Chapter 5 is forces. Chapter 8 is work and energy. Okay, students will demonstrate an understanding of atomic nature of matter. Remember, that was in the course description. That's chapter 12. It's called something about matter. I think that's its title, matter. Okay, students will demonstrate an understanding of sound. You better get that one because this is sonography. That's chapter 16. Students will demonstrate an understanding of electrical forces and fields and solve problems dealing with currents and circuits. That's chapter 17. Students will demonstrate an understanding of magnetic forces and fields and also demonstrate an understanding of capacitance, electromagnetic induction, and transformers. If you remember, those were all listed in the course description. Those are chapters 18 and 19. Now, why did I put those together? Because the sections that we're going to cover over 18 is very few, and then 19 are very few. So these others are longer chapters. So there's a test after each one of these. I combine these two chapters to be one test. Now that'll completely be up to Dr. McBool. So he'll probably go along with it this way. Let me show you in the table of contents what I was talking about. Okay, I don't know if this will be easily readable, but there's chapter, can you tell me if I've got, yeah, there it is. Chapter 5 is forces. You see that? We'll probably do all sections in that one. Okay? On the next page, next page, top of the next page in the table of contents is work and energy, chapter 8. A little bit further down, chapter 12, I believe it says matter. Yeah, there's chapter 12, matter. Okay, probably do all the sections in all three of those chapters. Okay, then chapter 16 is sound. That's the top of the next page. That's the heart of the course because that's what you're going into, sonography. And then when you get to chapter 17, look how long chapter 17 is. No way we're going to do all those sections in 17, or I wouldn't. I don't. Why? Because they listed what you had to do in electricity. They said, and let me go back and, let me remind you. It said electrical forces and field. Well, electrical forces, Coulomb's law, that's 17.3. That's the law that governs electrical forces. Okay, 17.4 is electrical fields. There's electrical fields. Okay, 17.5 is circuits. There, number 6 says electrical circuits. Now, notice the next thing it says currents. And this is series current circuit, circuits, series circuits and parallel circuits. Well, you can't analyze circuits without doing Ohm's law. So even though I don't have an arrow by it, we have to do Ohm's law, okay? But it's a really simple law and it's real easy to work with, okay? So that's one thing that you have to do in order to do what's the required others. Then we do series circuits, parallel circuits, and compound circuits. We stop there. So that's 17, 3, 4, 5, 6, 7, 8, and 9. Now that sounds like a lot. It is, but these are fairly short sections, most of them. Okay, then 18 and 19. 18 is magnetism. Introduction to magnetism is 18.1. 18.2 is magnetic effects of current, which is pretty important too. And 18.7 is magnetic forces on moving charged particles. Okay, so there are the 3 sections we cover in 18. 18.1, 18.2, and 18.7. And then the other part, chapter 19, that's alternating current electricity. Why do we do that? Well, there's AC power is mentioned there. I cover that because you really need that to do inductance. And remember, inductance was one of the things that were mentioned. And then capacitance. And capacitance is mentioned. Okay. Now, the one thing that I didn't mention is it says up there, okay, electromagnetic induction, that's in there. It's the transformers. And the transformers are mentioned in one of these sections. They just don't have it in the title. And right now, since I didn't teach it last fall, I don't remember which section it's in. Okay, but the transformers are in one of those sections, and that's what we're going to be covering. Now that's quite a bit, but it goes pretty fast. Okay, now this next thing is again how I taught the course. Whether Dr. McBool will continue this, I don't know. The following is a breakdown of how each student will be evaluated for final grade calculations by the end of the term. A test will be given at the end of each unit of study. That's chapter 5, 8, 12, 16, 17, and then combining 18 and 19. Okay? The lowest test score, now this is what I do. He may not do this. The lowest test score may be dropped. Okay? Now, with one exception, one exception, the last test counts as the final exam. So, or that's how I counted it. So that one can't be dropped. So 18 and 19, that test, when I taught the course, you couldn't drop that one, but you could drop your lowest score from the others. Okay? Now let's see, average of remaining tests will determine your grade for the course. Now if he wants to do something else, he can do something else, perfectly fine. If he wants to assign homework and give you a grade for homework, perfectly fine. If anything he wants to do, he can do. Now at the end, oh, by the way, the dean or whoever put this syllabus type stuff together, she was all over plagiarism. She was a former English teacher, so she just talks plagiarism every time she can. I can't figure out how you can plagiarize answers on a test. Okay, if you're writing papers, yeah, plagiarism is pretty important, but okay, anyway, we'll leave that alone. So if you're in the 90s, your average is in the 90, you get A, 80s or B, 70s or C. Don't go below that. Okay, try to stay up in the passing range. Okay, now I changed this next sentence here. It was rather bizarre. Here's how it was phrased before. It said, and I'm doing this from memory, I believe it's correct. The instructor never rounds down, always rounds up. And then they gave this very example here. For example, a 79.5 would be rounded up to an 80, of course. And then the next sentence said, but a 79.4 would round down to a 79. Wait, it didn't say that, but that's what you did. That's rounding down. If you always rounded up, that would be an 80. This is what I call normal rounding. So I changed the first sentence to be the instructor rounds grades normally, period. Okay, now let's move on. Dr. McDowell can do it any way he wants to. McDowell, I keep saying his name wrong. Here are the things they say about attendance. Oh, here's where the virtual classes come into play. So read here about this. Now, let me make sure nobody else has tried to come in the course. I haven't seen anybody. Oh my goodness, there's Janiyah has been waiting and you didn't say anything to me. And it's H-O-M-A-S. Is that what you said? Y'all are really good. H-O-M-A-S. You got it right. So Janiyah is trying to come in. And it's taking a long time, which is not a good sign, but she's in. Let's see if she's got sound yet. I don't see Janiyah yet. There she is. Don't have a microphone yet. Okay. Janiyah, are you able to get sound? I don't know how you can answer that because you don't have a microphone, but hopefully you're here. Okay. And I don't see your block because I've got the syllabus up now. So if you can see me, that's what we're doing. We're doing the syllabus now. So I'm going to punt out of this again and go back to this. So here's the attendance, how they do it. This will, I think, has to be stay like this. This is what the school requires us to write. I'll let you read this to your heart's content. If Dr. McBool wants to go over anything with you, I'm sure he will. They talk about withdrawals here, and here's what I say about this. Okay, now, number one, you're in the diagnostic medical sonography program. That means your best person to talk with is the lady who's in charge of that program. I'm right now going blank on her name. Catherine or Kathleen or something. What's her name? Warner. Okay. Miss Warner. Okay. That's who I would talk with. Okay. But here's what I usually tell most of my classes. Okay. If you get hopelessly behind in a class, it's better to withdraw than it is to get a D or an F. Okay? And the reason is withdrawal does not hurt your grade point at all. Whereas D or an F, unless you've got a really low grade point, a D is going to hurt it, and an F will always hurt it. Okay? So, and then I'm pretty sure, I don't know this for a fact, but I'm pretty sure that, was that someone trying to come into class? I don't see them. Let me see if somebody is trying to come in. Yep. Christivia Dozier, Marengo County. Oh, I don't know what that means. Let's see if I can find Miss Dozier on the roll book. Okay. This is so crazy. Let me go here, content Google. There it is. Okay. Let me get the attendance. I told you I had a good memory. It's just real short. Wasn't her last name? Yeah, there she is, Christina Dozier.
It's Christavia, and I'm sorry.
Christavia.
I tried to join early, but it won't let me.
I know this. I don't. Zoom is usually pretty good, but I think sometimes it's bandwidth issues and other things like this. And um, so I'm glad you're here. You haven't missed a lot. And in addition to that, I'm recording the session. And once it's over with, I'll post it on Blackboard on YouTube video. So you'll be able to pick up anything you missed. Let me, while we're here, just check and see if anyone else is here that I may have missed. Okay, Jasmine Davis. I haven't seen her yet. If Jasmine Davis is here, speak up now or forever hold your peace. No. Okay. Charday Giles. I haven't seen her name yet. Oh, look at this. Great attendance. Letitia Rogers. I haven't seen her name yet. If any of you know any of these people and you know they've been trying to get on, that's only 3 people we're missing. And I don't see Jania's name here, but I'll make sure you get marked present. Maybe they just don't have it in Blackboard yet. I don't know why. Okay, so let's go back to screen sharing, which was the syllabus. Okay, and let me get out of this. Okay. All right, so there was withdrawal. Like I was saying, withdrawing is better than making a D or an F. So, and the last day to withdraw is usually very late in the term. So if you do get in really bad shape and it looks like you're going to get a D or an F, I would suggest you withdraw. Now, talk with Miss Warner, talk with Dr. McBool, talk with anyone. I won't be here, so talk with anyone, see what they say. But I think a withdrawal is always better than a D or an F. Now, if you're on financial aid, like Pell Grant, they will pay for you to retake a class once. Okay? They'll pay the first time and for you to retake once. After that, they won't pay a third time. But guess what? If you make a D or an F, now I don't know this for a fact, but my guess is if you make a D, you probably aren't going to be able to use that to get in the DMS program, so you're going to have to retake it anyway. I know an F you're going to have to retake. So guess what? If you're going to have to retake it anyway, a W doesn't hurt your grade point average, a D or an F will. So I've talked too much about that. Makeup work, well, I'll let Dr. McBool handle that. Most of the time when I've taught this course, I give take-home tests. And maybe y'all don't like take-home tests, but that's what I do because I really want you to work through the problems and figure out how to get the answers. And usually in class, there's so much time pressure and stuff, people freeze. So I want you to work through it and be able to get answers. Talk with Dr. McBool and see what he wants. If he wants it in class, it'll be it. In that case, the makeup work will make sense because but I'll let him set his policy there. I'm not going to do it for him. Okay, lateness policy. Sometimes you'll have trouble getting in. Fine, just get here. Okay, so I don't do that. Academic integrity. Okay, just do this. Conduct yourselves with honesty and integrity at all times. That says it all. Again, they have plagiarism here. Again, they have cheating here. Let me just say, don't do it. Okay, that's all I want to say. Professional decorum. Now this I think is almost ridiculous, especially in a virtual class. I can't tell if you're texting or doing something else on the internet, so why mention it? Okay, I can't tell if you're sleeping. Well, I can see a few of you and tell you're not sleeping, but most of you I can't tell. Speaking out of turn. Well, if you ordering lunch or supper and you got your mic on, I'll mute you, but that's about it. Eating or drinking, I can't control that. Unnecessary traffic in the classroom, one of you is having to walk the halls, I can tell. So, but look, this doesn't make any sense, okay? Or wearing inappropriate clothing, sunglasses, hats, and earphones. Hey, I've got earphones on. Well, that's because I'm hard of hearing. and otherwise I wouldn't get you. But there's a second reason. If I don't have the earphones on, which has the microphone here, if I turn my head, you can't hear me because this is a very directional microphone, and if I were looking at the book or somewhere else, then I fade out. Students griped about that. My wife bought me these headset so I can turn my head anywhere I want to and you can still hear me. Okay, so that's sort of a nebulous little thing there, but they put it in there. They say we can't do it. Course concerns first. If you have concerns, please talk with the instructor. Now, if it's me, talk to me, okay? If that doesn't help you, then go to the department chair. Now, I used to be a department chair, so go to me again. No, I won't be here after a month. Your new department chair will be Dr. Tracy Wilson. She's chair of natural sciences, okay? And she may become chair of mathematics too. I used to be chair of mathematics and she was natural sciences, so go to her. If that doesn't work, keep on going up the line. You can go to the associate dean, Dr. Carl Pruitt. There are ways you can file formal complaints, all sorts of things. You can go to Dr. Shree Davis, but follow the chain of command. Go all the way up to the vice president, Dr. Crawford, or the president, Dr. Cynthia Anthony. She is fantastic, by the way. So there's a website. It has on there all the ways that you can go to do the formal complaint process. Statement of discrimination, harassment. I add one more thing here. Bullying. We don't tolerate it. We don't want it to happen. But how do you do that in a virtual environment anyway? I don't know. But there it is. American with Disabilities Act. Okay, if you do have any kind of disability, please follow these guidelines because I can't do anything, but Dr. Renee Herndon and Ms. Janine McCoy-Jones, they will handle this. They're professionals at it, and they will let the instructor know if there's any kind of special accommodations we have to make for you. We are glad to do so. We want you to succeed. Please get the information to them, and they will get the information to us. Now, this course calendar, again, this was from last summer, doesn't apply now. I don't know if Dr. McDougall will update this or not. He can delete it. It doesn't really matter. Okay. Now, here's something that does matter. Now, not as much to you folks, though it may matter to some extent. You're here today. You're getting marked present today. But for those 3 or 4 students who are not here, they will need to print this page, sign it, and email it, or however get it to the instructor. Why is that important? This is the only time this class meets this week, first week of class. And this new package we have, banner, that we work under, it will kick people out if they don't attend the first week. So you 16, 17 people, however many you are, you're in the course. Okay, now you got to pay too. If you haven't paid, they're going to kick you out later. But if you've attended, they're not going to kick you out immediately. Okay? For those people who aren't here, those only 3 or 4 students are, it seems like, if they don't get something in this week, they will be removed from the class. Okay? And I don't have any way of doing it. I think I'll try to email them this evening and let them make sure they understand they've got to turn in something this week. And this would be what I say, the student acknowledgement form. Email it to myself or Dr. McDougall. He doesn't have a Lawson State email yet, so send it to me. I'll forward it on to him. All right, any questions on the syllabus? He will update this, make it his. So this is just the bare bones, basic information. All right. Let's go back then to, if there are no questions, let's go back to goodness gracious, this is such a pain in the neck. Every time it comes up, I have to re-enter. Okay, I don't know why Outlook is such a pain in the neck, but it is. I really don't like any Microsoft product at all. I know everybody lives by them, but I don't like them. They're just, goodness gracious. Your sign in timed out. Please sign in again. I just did that. Okay. Wait a minute. This is password. Stay signed in. Yes, I've said that every time, and it still come back every time making me sign in again. Okay. As you can tell, I don't like Microsoft. Okay. You may now close this window. Thank you very much. I don't know why it's open anyway. Okay. Let me go back to I don't want Outlook. Maybe that's part of the problem. And what we were looking at before has now disappeared, so I'm going to have to go back. Okay. Oh, that's right. I went back to attendance. Okay. Okay. So still no Jasmine Davis, no Sharday Giles, and no Letitia Rogers. Okay. So let's go back to Blackboard. We're in Blackboard, but all right, there was course syllabus. That's where it'll go. It's not there yet, but he'll put it there. Here is a course syllabus agreement. Now, it's not there, so you can't go through this process. Let's see. I guess I'm going to have to put it there. It's just not the right syllabus. Okay. Oh, there it is. It is there. The syllabus is there already. Now, it may not be his syllabus, and then you can go through this procedure to send Dr. McBool or me or whoever that you understand the course syllabus. Or you can print it and email it to me. Either one. Or send it as a Blackboard message. Any way you can get it to me or Dr. McBool, get it to us so we can get you marked present. Now, again, I'm preaching to the choir here. It's those 3 students who weren't here. They really need this. Okay? So let me get away from course syllabus. They pulled it over. Oh my goodness. You know what they did? This is Physics 112. I know what they did. There is a Physical Science 112. They pulled over the wrong course. The administrator, the IT person, did the wrong course. It's PHS 112. Yuck. You just can't get good help these. Oh, I didn't say that, did I? Let's see if I can do something to bring that in here. So this was, I didn't look at it. Yep, you're right. That's PHS 112, not PHY. So I'm going to not do that. I need to delete it, and I don't see how to delete it. So what I'm going to do, insert a link for this. Oh man. Okay, I have to worry about that later. Let me see if up here if I can do it. See if I can delete this now. Okay. Okay, let me see if I can delete that one. Ah, it did. Okay. Now let's see if I can insert a link. Right there. And I'm really fast at this, you can tell. I'm old and decrepit. This is not my bag. Okay, there's the syllabus. Thank you for pointing that out to me. This time it says PHY112 Syllabus. That's the correct one. Okay, thank you for pointing that out to me. That probably means most of the rest of the course is wrong. Okay, sorry about that. But anyway, and there's your course syllabus agreement. They probably want you to do that anyway, but you're here, you don't have to, but it's a good idea to go on and get it done. Okay, so I'm going to save that so the other one doesn't stay there. And there it says the right one. And let's see, this toolbar, you can't see it, but I can. It's right in the middle of my screen, so I'm going to move it down here to the bottom. Okay, now let's see what else we have here. So y'all have already been navigating the course. That's good to hear. If you haven't, get in there and get to know it. Okay, textbook and other required course materials, same thing. That, oh, I bet you this is wrong too, isn't it? No, it does. Okay, it doesn't list it there. Okay, so I'll let him worry about that. Okay, now the course weekly schedule. Frankly, folks, this is a pain in the neck for us as instructors. I don't know how y'all like it as students. Have y'all dealt with this before? Okay. This, I think, is for online classes, so I'm going to forget that. So don't worry about that. That was online. This is the one. Oh, okay. Instructor contact and office hours, that's where he'll put his information. He'll also put some more information here. Okay, this is Dr. Bryant. This is not Dr. McBool. Okay, Dr. Bryant is our regular physics instructor. Instructor. However, he's teaching another class that conflicts with this one, so that's why we brought on Dr. McBool. Okay, and Dr. Bryant had all he could handle anyway because he's an adjunct and he's not supposed to have more than 9 hours, and he has 12 right now. So, all right. So that's wrong too, but Dr. McBool hopefully will correct it. Here is where I was thinking, and this is the weekly assignments and activities. This is the real big pain in the neck for instructors. Okay, week 1. Now there's probably nothing here, but I've said that before and there's always been something. The weekly to-do list. Is anything there? No. Okay. I guess I should do this since I'm doing the first week. So I may put something here. It's going to be after the fact, so it'll just be to satisfy the administrators. Okay. But this part is exactly here. Okay. So I'll go in and do something there. All right. Instructional materials, lesson PowerPoints, and that kind of stuff. Let's see what they've got here. Boy, this is slow. They don't have anything here. I will put the PowerPoint slides, link that in. Let me tell you something about the PowerPoint slides that come with this book. Remember, I didn't choose the book. Somebody at Wallace Hansville or somewhere chose it. The PowerPoints for this text are absolutely pathetic. Okay, so there are some, they are awful. They're some of the worst I've ever seen. I mean, what they've got is good, but they just skip pages after pages after pages, and there's another PowerPoint. And then skip pages, 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 and there's a PowerPoint. And they're pretty pathetic, okay? Recorded lectures. Now, here's what I'm going to do for you. Remember I said that I've recorded all the classes from the last time I taught the course? I'm going to put the link here. It'll be a YouTube video link, and tonight's class will be on there. And I'll take off the syllabus link from that class, but the rest of them will be on here. Now, I don't think I had any other instructional videos. Handouts, I probably won't do anything there. Labs, there's no labs for this course, and etc. I don't think of anything, etc. Okay, so basically it's going to be the PowerPoint slides and the lectures. Now, when I put them out there, if you go to that link, it's a playlist. You go to that, there'll be every course that I taught when I taught the course. Okay, every class meeting. So you can go to the chapter 5 and see what I did. Compare it to what he did. It may give you more insight. You may find that I'm really lame and that he is much better. Probably going to be the case, but there you'll have something to back up, especially if you have to miss class. At least you can kind of keep up with it. So I'll put that out there, and whether he wants to keep it in there or not, that's up to him. Okay? That's why I was hoping he'd be here tonight, but he's not. Okay? Now, textbook link there. I don't have that. Discussion, only if y'all want to do a discussion. Week 1 assignment, I usually don't do that. He may choose to. Faculty instructions, you don't see that anyway. Week 1 assessment, I doubt if you'll have one this week. No, we won't. Okay, except maybe your your syllabus acknowledgement page. Okay, this is how to submit an assignment on Blackboard. I'm not going to be doing that. If he wants you to, he can. Okay, these that have slashes through them, you can't see them anyway, so don't worry about them. Every week goes to that same stuff. Okay, I want to say garbage, but I'll say stuff. Okay, so most of the time it's just repeating. Of course, the material you'll cover will be different week by week, and he can put anything in there he wants to. So there are the weekly activities. And frankly, this takes me, when I was doing it, oh man, okay, it took me hours on the night before class to get all that done. So I was not a happy camper with that. So there's the weekly assignments activities, all 16 weeks of the term. The live virtual class meeting information, I doubt if they have anything here. I don't know what Dr. McBull will use. I think he's going to use Zoom, but if he doesn't, he may use Blackboard Collaborate. Now let me go back up here in Blackboard. This is how you access Blackboard Collaborate. If he uses that one, this is what you do. Have any of you ever used Blackboard Collaborate? No. Wow. I thought some of you may have. Most of you used Zoom before. Yes. Okay. Everyone that's used them both that I can recall says they far prefer Zoom to Blackboard Collaborate. But others love Blackboard products. I don't care for them. Okay. Okay. So let's go on back down here again. He will put in anything here. Like for me, when I was doing it, sometime the evening before the class meets, so that would be usually on Tuesday evening, I would post the link, the invite to Zoom. And so look for it sometime the evening before class. I don't know what he'll do. Now, usually, as you can tell, I don't give a single midterm exam. I give tests on every chapter. So I didn't use the midterms at all. My final exam was the last chapter test. Now, if he chooses to do a comprehensive final, that's perfectly fine with me, and he can do that, okay? Whatever he wants to. So I didn't put anything there. I'll leave it up to him, okay? Now, there's online resources for virtual and hybrid students. There may be something in there that you'll find useful. And here's a couple things. And this is interesting. I don't know what this is and who put it here. A new link 1921. That was last week, right? Ultrasound physics for tutorials and physical science tutorials. Now I don't know why the physical science is in here, but ultrasound physics tutorials, that looks like it would be a great thing to look at. Have any of you looked at it? You did. Did you find them useful? Okay. I don't know what they're about, but it sure sounds like it would be very useful. Now here's my guess. I'm guessing that someone looked through, well, here's my first guess. I bet you Miss Warner did that, but I don't know that for a fact. I bet you she requested Jim Mankiewicz, who is our IT person, to put this link in here. Now, he may have seen the one for physical science and decided to put that there thinking this was a physical science course. It's not. So that one, did anyone look at this one? Did you find that helpful? You did not. Okay. This I would think would be very helpful. I haven't looked at it, so you're on your own. All right, so that's basically the outline of Blackboard Ultra. I know that was fast. I know it was furious. I know there's not much you could look at because he hasn't put anything there, but I'll try to go in and put a little bit there for this week anyway. Okay, I will put the YouTube video link, playlist link, so you can go to that if you choose. He may take it out. That's his prerogative. All right, so with that done, let me now go to I'm trying to remember where it is now. I'm pretty sure it's, oh, I didn't need to do that. I'll do it here. Okay. Okay. You don't need to see the test yet. So let me back off from this and go to, back off from that and go to, I think this is where I put the PowerPoints. Yes, that's the PowerPoints. Why they're in reverse order, I don't know, but let's open the first one. All right, what do we have? We have about 40 minutes of class time left. Let's get started in the class. Okay, and again, anyone who's not here, of course they can't hear this and they won't know how to hear it, but this is, let's do slideshow from current slide. All right, now I take it that probably very few of you have a book yet. Sadie, did yours come in yet, or is it still coming?
It's still coming.
Okay, about how long a wait do you have with Chad?
I don't know. I haven't checked it yet.
I see. Okay, and who was it that used Amazon?
It was me.
Okay, have you gotten yours yet?
Yeah, students get the free 2-day shipping with the Amazon Prime.
Oh wow,
Mine
nice.
will be tomorrow.
Oh, yours will be. Okay, that sounds good. Say again? Did someone?
I think he said it wasn't.
This is not Cengage. This is Pearson. You see right down here? Pearson Education. Oh, you can't see that. Okay, let me get so you can see that. All right, let me go back to current slide. All right, see, this is Pearson Education. It's not Cengage. Sorry about that, but as I was describing before, this is something that somebody else came up with this. Now, I've got to pause for just a moment here. My wife is here, and she usually doesn't like to hear me teaching, so I'm going to close the door so she doesn't have. The reason I know she's here, I can smell food downstairs, so I wanted to close the door because I'm hungry. Okay, never mind. That's just, I'll be right with you. Just lost my microphone. Okay, I'm back. Can you hear me? Okay, you probably could hear all the other stuff too. Okay. Now, chapter 5 is dealing with force, and that was the first thing, one of the first things mentioned after they mentioned electricity and magnetism in the course description. They said in order to understand this, you've got to understand forces. So that's what we're doing in chapter 5. Okay? And that's a picture of the book, but that's also the picture at the first of every chapter. Okay? And I don't think I'll go into, well, I'm in chapter 6. Why am I in chapter 6? Let me turn back to chapter 5. Okay, chapter 5, force. Okay, and you see that picture shows up again, or something pretty close to it. The Golden Gate, well, I think it's Golden Gate Bridge. Okay. All right. Now, no one has a book, so I'll go in this in gory detail. Okay. In fact, I may actually write some of this down for you. I think I'll do that. Okay. Let me just show you. Here's the first slide, which is several pages from here. No, 1 page away. Okay. But before we go there, let me go to a new share here. And this is the whiteboard. Okay. Now I'm going, excuse me. Sorry, I couldn't get the microphone out of the way in time. I wanted to make sure y'all were still awake. Okay. Remember, no sleeping in class. Okay. Thank you. And now I've got to do a little bit more housekeeping, because they put these taskbars right in the middle of the white space, so I have to move them so I can use the white space. You can't see it, but it keeps me from seeing it. Okay, and this I think I will go on and just type for you, because you don't have your book. Okay, well, let me do it here. Okay. Well, I thought I would type it. There it is. Well, a force is a push or a pull. If any of you had high school physical science, you probably learned that very definition there. A force is any push or a pull. The book actually has any. That's a very simple definition, but it's fairly accurate. A push or a pull. Now later we'll get into defining forces a little more physically, okay, a little more scientifically. This is just a statement. A force is a push or a pull, okay? Now, basically, you probably can't see this, okay? Now, here's my book, okay? I'm going to push on the book. Well, because I'm pushing on it, I'm also holding with the other hand, and it's not going anywhere. I'm still exerting a force on the book. A force is something that's capable of changing the motion of the book. Well, this book isn't changing its motion any as I push on it, unless I release this hand, and then sure, it changes the position of the book. So a force is a push or a pull that is capable of changing the situation with that object. So forces always act on objects. Here's another thing about a force. A force is a vector quantity. Now, what in the world do we mean by vector quantity? Okay, now I'm going to do some backtracking here. This is stuff that would have been covered in earlier chapters, but we're not doing the earlier chapters. So let me just give you an idea. Okay, here's a piece of paper. It has whatever on it. Okay, what if you were here and you went there? Okay, that's pretty simple, right? You moved. Well, what is involved in moving? A change of, now I'm going to give you two terms here, position or displacement. Change of position or change of displacement. Okay, now a change of position is usually measured in a length measurement. A meter, an inch, a foot, a millimeter, a furlong, a whatever. Some type of length measurement. That could be described as a distance. Okay? Now, another way to describe that is a displacement. Okay? Now, a distance is how far it is from here to there. That's all. How far it is from one place to another place. How does a displacement differ from a distance? Well, displacement from here to here would be not just how far you went, but in what direction. Okay? Now, I used to give this an example when we had classes on campus. I would say, we live in Southside Birmingham, and every morning when we were on campus, I would drive let's just round it to about 20 miles to the Bessemer campus, because that's where my office was. Okay, the classes usually met on the Birmingham East campus, but let's just use Bessemer campus. I would drive there. That would be a distance of about 20 miles, closer probably than 17. 17 miles, no, I guess 20 miles from here to there. That's a distance. 20 miles to the southwest, that would be a displacement, because not only does it have a magnitude, the 20 miles, it also has a direction. Now, what's the difference between? A distance is a scalar quantity. All it is a number, sometimes with units or not. 20 miles. No direction implied. Okay? A vector quantity also has direction. So a displacement would be 20 miles to the southwest. Now, when I drove home the next night, I would drive, if I went the same route, 20 miles to the northeast. Okay? That would be a vector quantity. It has a direction and a magnitude and a displacement. I'm sorry, magnitude and a direction. I can't talk tonight. Okay? That's the difference between a scalar quantity, which is just a number, may have units or not, but a vector quantity has that same magnitude, but it also has a direction. Well, guess what, team? Distance is a scalar quantity, displacement is a vector quantity. Now, I'm going to give you a little more background information. We're not at forces yet, but we're getting there. In physics, and we'll be doing that in this course a lot, whenever you get a good useful quantity like distance or displacement, usually a really good thing to do is take a time rate of change of it and get you a new quantity. Well, what's the time rate of change of distance? You know this, you probably don't think of it in those terms. Speed. Because speed is what? Miles per hour. How far you went and how much time it took. Okay? Speed, distance divided by time. Okay? Well, if displacement is a vector quantity, distance is a scalar quantity, time rate of change of distance is speed, the time rate of change of displacement, which is a vector quantity, would be velocity. Now, I bet you before now, probably most of you use speed and velocity as if they were synonymous words. They're not. Velocity is a vector quantity where speed is a scalar quantity. Notice SS, scalar, speed, VV, vector, velocity. Okay? That's how I remember, but no, I know them anyway. Okay? Well, now that we've got a velocity, well, more likely a velocity, let's take a time rate of change of it. What do you get? An acceleration. How much is your velocity changing with time? If your distance is changing with time, that means your object had a velocity. If your velocity is changing with time, think about your car. If you're driving along at cruise control at 70 miles per hour or 20 miles per hour, you're going at a constant speed. Your speed or your velocity is not changing. Okay? So your acceleration is zero. If you put the pedal to the metal and press that accelerator changes the velocity, right? You accelerate. Now, what you may not realize is the brake is also, in a sense, an accelerator because it's changing your velocity. Only this time it's changing in a negative direction. So an accelerator is a positive change of velocity. A brake is a negative change of velocity or a negative acceleration. Okay? And this is even more surprising. The steering wheel is an accelerator. What? Well, think of this. Remember, velocity is a vector quantity. It has a magnitude and a direction. So if you change the direction, you've changed the velocity. And a change of velocity is an acceleration. Okay, that's all background information just so you can understand that next term, forces are always vector quantities. A force is a push or a pull in a given direction. Now, a lot of times in this book, the problems will do, they won't give you the direction. They just say the force is so many newtons or something like that. Well, that's perfectly fine, but just know a force is a vector quantity. And they say that in the book, but then a lot of the examples, they don't give you a direction. Okay, now, since I kind of pushed out there something about units, okay, let me give you the units for a force, okay? Now, most of the time we deal with two measurement systems, okay, because we live in the U.S. If we live just about anywhere else in the world, certainly any industrialized country, we would only need to know one system of measurement. The metric system, or more precisely, the SI system. SI stands for System International. French, they put the noun in front and the adjective at the end. Most of the time in English, we put the adjective in front and the noun at the end. They say System International or Système International or something like that. I don't speak French very well. So the units for force is a Newton. That's the SI unit for force. Now, this is getting into some other territory that it's a little unfair to you because you haven't had the first 4 chapters. But the force unit is in the SI system. Whoa, where are you doing there? Okay. Okay. The SI unit for force is the Newton, capital N. Why capital N? It's named after Sir Isaac Newton. Okay? It's written N-E-W-T-O-N, like a fig Newton, but only different. But it's capital N because it was named after somebody. And for lack of a better term, the U.S. customary, because we're about the only industrialized country that uses it. A few countries that do most of the trading with us also use the U.S. system. In the old days, it was called the British system, but the Brits don't even, well, they still use it some, but they are SI nation now. But the U.S. system for a force is a pound. I can't type. Is a pound. Now, its abbreviation, maybe I should put the abbreviation is LB. Now, where that comes from, I'm not sure. My guess is that whatever language it first came from started with L and had B somewhere in it. But that's the unit. But you're probably used to seeing that. The U.S. unit for force is a pound. The SI unit for force is a Newton, and its abbreviation let's see. I don't know how to get back there. It's just capital N. So I'll just put it here. Okay. It's not quite in line with it, but that's it. So that's the unit there. Now, just to get an idea, it takes 4.45 newtons is equal to, approximately equal to anyway, 1 pound. Goodness, the food smells so good I can't stand it. Okay. 4.45 newtons is approximately 1 pound. It's not exact, but it's pretty close to it. Okay? Now, as I sort of hinted at before, if you didn't catch the hint, we were going to give a little bit more substance to what a force is besides just a push or a pull. Well, one of the reasons the SI unit was named the Newton was Sir Isaac Newton was the one who did much of the early work in identifying forces and defining forces and using forces, okay? And he did this in just about the most brilliant, far-reaching, incredibly insightful paper called the Principia. Now, why Principia? He wrote in Latin, okay, and I don't speak Latin, but that's what they call it. It was a big, long title and basically meant principles of mathematical motion or something like that. But its shorthand was Principia. And in the Principia, he came up with 3 laws of motion. Now, I say he came up with them. Actually, the first one had been introduced by a guy who preceded Newton by 1 generation, and his name was Galileo Galilei. Believe it or not, his first and his last name were almost the same, but they always just call him Galileo. Now, Galileo came up with this first law of motion, but he didn't call it that. But what it's often called is the law of inertia. And if and when you get your book, I'm going to put this back where it was so I won't forget it or lose it. On page 124 in your book, there is the law of inertia, Newton's first law. Actually, initially developed by Galileo, but not formalized. Newton came along and made it a lot more precise, I guess you would say. And you may have heard this. If you've ever had a physics or physical science course, you probably have heard this before. A body that is in motion tends to stay in motion at a constant velocity, constant direction, unless it's acted on by an unbalanced force. Or a body at rest tends to stay right there at rest unless it's acted on by an unbalanced force. Okay, now if you remember my pushing on the book, okay, when I pushed on the book here, because I was holding it with the other hand and not letting it move, this force here is balanced by the force on this hand, okay? That is an unbalanced force, so that force does not produce motion. However, if I was to sit this down on the table, I just can't show it to you, and pushed on it, and it took off and went, okay, I just lost my place, then that would be, it would take off in motion and stay in motion unless it was acted on by an unbalanced force. Well, you might say, hey, no it wouldn't. I know better than that. If I were to push on that book, it's going to push a little ways and then it's going to come to a stop. It did not stay in motion. And you'd be absolutely right. Except for the fact there was an unbalanced force. Does anyone know what that force is called? Friction. Absolutely. Way to go. Okay? Friction is the unbalanced force that makes it stop. Okay? If you were out there in outer space, and that's not where I'm telling you to go, but if you were out there in outer space and you pushed on an object, then it's going to take off and it will not stop moving unless you pull back on it again. Because out there is no air resistance, there's no friction, there's no gravitational force, nothing to stop the motion. And that's pretty interesting to think about. So that's basically your first law of motion. They call it sometimes unbalanced force. They also will call it an outside force. Okay. Now, the property of a body that causes it to either remain at rest or to continue moving in a constant direction and constant magnitude is called inertia. Okay, I'll write this one down too. Let me get my book in front of me so I don't do it incorrectly. I'm doing this because you don't have your books yet. Is the property of a body that causes it to remain either at rest if it is, this is a wordy sentence, at rest, or to continue, if I could spell, I could type, to continue moving with a constant velocity unless an unbalanced force acts on it. Okay, big long sentence, a bit wordy, but I was trying to get it close to what the book has. They said upon it. I just want to type on it. Oh, what is going on here? Why did it do that? Let me see if I can. I've never had that happen before.
I think you just move the box. Click on those words and see if it'll move them back down.
Okay. No, not. I see where they came from. I want to get rid of them. Okay. Let me see if I can do that. Let's see. Whoa. All right. I think I got rid of all of them, didn't I? Okay. Okay. Let me type them back in there. Is the property of a body that causes it to remain at rest if it is at rest, or to continue moving if it was. Now, here's what I was trying to do. Catch that button and spread it out here. Okay, so it doesn't take up so much room. Okay, that's what inertia is. The property of a body that causes it to remain at rest if it is at rest, or to continue moving with a constant velocity. What do we mean by constant velocity? Constant magnitude, constant direction, not changing either speed or direction. Constant velocity unless an unbalanced force with a space in between that acts on it. Isn't that got an S on it? Yeah. Sorry, I don't know why. One thing, this is not my usual computer, and it's not nearly as sensitive as mine, so I think I'm hitting a key and it doesn't stroke. Okay. Now, that's where we get to this guy right here. That one. Oh, there he is. That guy is pushing on this thing. It looks like a big old box or something or another. He's pushing in this direction. Now, what I can't tell is if he's moving it or not. There's no way to tell that here. Okay? If these arrows are the same, he's pushing in this direction, guess what's happening down here? Friction. That looks like a pretty rough driveway or something like that, concrete driveway. I don't know how big the box is. You can't really tell here. If it's got enough friction there, he may be pushing in this direction at exactly the same force of friction down here, then he's not moving it. Or if it was already in motion and he's pushing in this direction and it's encountering the same resistance in that direction, if it was already moving, it continues moving at the same speed, constant velocity, straight line motion, because that's redundant, because that's what inertia is. That quantity, that property that keeps it moving in one direction. Now, if it's at rest and he's only doing the same force that friction's pushing against, it's going to sit right there. He can push till the cows come home. If he increases the force up here until he overcomes the force due to friction, then he'll get it to move. Okay? But then once it's moving, he can continue with the same forces down here, and it'll continue moving because there is no unbalanced force. Now, if it's moving and he pushes with a stronger force, then it's going to speed up, because that's what acceleration is. If you do a force on an object in motion and there's no unbalanced force about it, it goes in greater motion. Okay, so that's the figure that's on your page 124, and that's the first of the sorry slides in this section. Any questions on that? Okay, for some reason I've lost my clock here. Low battery. Okay, I've still got about 12 minutes. Okay, the next slide is pages away. Pages and pages. We're not going to get to it tonight, so let's go back. All right, now I don't know if you've seen this happen before. Well, let's do another one. Okay, here's a situation. This car could be going along at 70 miles per hour. Okay, what? Okay, it's going along at 70 miles per hour on a straight, flat interstate highway. Okay, what's the net force on that car? Zero, because it's not accelerating. Okay, remember, a net force is going to produce motion. If it's going at 70 miles per hour, constant speed, not going up or down a hill, it's going to have a zero. Now, does that mean there's no forces acting on? No, it doesn't mean that at all. You see, your tires are pressing against the road, those down arrows you see there, pushing the car forward, but it's running into air resistance, it's running into road resistance, it's running into all kinds of resistances. But if you didn't have the pedal to the metal there, you were with no force, it's going to slow down, because the air resistance, the friction of the road, are going to slow it down. But if you have the same force in this direction as you have in that direction, the car is going to go at constant velocity, not changing direction, not changing elevation, and not changing speed. Okay, now here's another car. This one happens to be on ice. And hopefully you've never had this experience before, but if you have, you realize you are completely not in control of that car, okay? Because you can do whatever you want to that. If that is really slick ice, you can turn the wheel, it keeps going in the direction it was. Why? Because ice is basically almost zero friction. So you could accelerate your wheels, they're just going to spin. Same thing with mud. If you're in red clay mud, you can step on the gas and you just sit there and spin. But on ice, turning the wheels doesn't do any good. Pressing this accelerator doesn't do any good. Pressing the brake doesn't do any good. It's just going to continue in the motion that it was going. Its inertia is going to keep it moving, because you cannot exert an unbalanced force on it. Okay? Now, they show you a couple tricks here, and you can do it this way. I've seen it done on a tabletop. I'm going to try to do it in my hand. Okay, I'm going to put my handy dandy piece of paper here on the book, and I'm going to put my eraser on the piece of paper. Okay, now I'm going to pull very quickly and in a real quick manner on the piece of paper, holding the book still. Well, you see the eraser moved a little bit, but not very much. And why was that? Because there was fairly little friction between the eraser and the paper. If I had done something else like a pencil or a pen, here's something that might do a little bit better. Okay, it's the cap for a red ink pen. Okay, if I pull on the paper, see, it stayed right where it was, because its inertia tried to keep it right in place. It didn't want to move because of its inertia. It's the property of an object to stay the course, stay in the direction and position that it was. if you've ever been on a bus and you couldn't get a seat and you're standing there hanging on to the strap or the pole or something like that, if that bus accelerates forward, you feel like you're thrown backwards. Well, you're not thrown backward. What it is, you're trying to stay where you are and the bus accelerated out from under you. Okay? Or if he slams on brake, you tend to go forward. No, you're not really going forward. Yeah, the bus is slowing down under you. You're trying to maintain your inertia. If he turns sharply to the left, you bang against the right hand side. Why? Because you're trying to maintain your state of motion. Your inertia is keeping you in place. Okay? That's what inertia is. Now, what does inertia depend on? Okay? I just did it in a sense with the pen cap and the eraser. The eraser is heavier than the pen cap. The pen cap's really light, okay? And it just fell. It also has more friction, and that was the main reason. But an object that is larger has more inertia than a smaller object. Think of this, okay? Jimmy, you're there. I'm going to throw you a ping pong ball as hard as I can, okay? I'm going to hit you right smack side of the head if I could reach it, okay? Do you get very angry at me? No, okay. Right. But if that was a bowling ball, oh yeah, okay. I would never do it either. I wouldn't throw a ping pong ball at you anyway. But the reason is there's more inertia in the bowling ball, so it's going to take a lot more force to get it to stop. And I don't want that force to be your head. Okay? Whereas the ping pong ball has very little inertia, it's going to stop may even before you get there. The air resistance might be enough to make it stop. So inertia depends on mass. Mass and inertia are mass is almost a measure of your inertia, okay? And that's exactly the next statement. Let's go back to our whiteboard. And let's get that one written down too. Oh, it's not there anymore. Okay. Okay. Mass is a measure of the inertia of a body. Okay, let's bring that one out some. And by the way, I don't know if you find this useful or not. If you look at the word inertia, what do the first 5 letters spell? Inert, which means it's not doing anything. Well, that's if it's at rest, it's not doing anything, and inertia is a measure of that, or the characteristic of that says it's going to continue not doing anything unless you add an outside force to it. But see, inertia also has to do with moving. If it is moving, it tends to keep moving unless it's acted on by an unbalanced force or an outside force. All right, so let's see. We got 3 minutes left. Let me introduce force and the law of acceleration. This is the second section. That was 5.1. There's no problems in 5.1. Let's move on to 5.2. I probably should have done this for the first one too. I didn't think about doing it at the time. But I'm sorry I forgot to do that. That would have been helpful, but it was a lot of typing. Okay, so I'll do this one. Most physics books don't call it this, but this one does. I can't get the right keys. Okay. The law of acceleration. Frankly, I've never heard it called this except for this book, but it makes sense. Okay. Is Newton's second law. Now, I talked about Newton's first law, but I didn't write it down. if I, goodness gracious, this is a terrible. Okay. Now, here's what it is. The total force acting on a body is equal to the mass of the body times its acceleration. Now that's why I wanted to go back and talk about velocities and displacements and things, so you get an idea of what these words were. Otherwise, I just type them in here and you don't really have a clue what is velocity, what is acceleration. That's why I took the time to do that earlier. Okay, actually I think I'll do it this way. Okay, now let's compare Newton's first law with Newton's second law. Newton's first law, an object continues in its state of motion, whether it's at rest or moving in a straight line, constant velocity, maintains its velocity unless it's acted on by an unbalanced force. That's Newton's first law. Okay? Now, the second law, well, what if there is an unbalanced force? Then that's the total force acting on the body is going to change its velocity, right? Because the first law says it's going to maintain its velocity unless it's acted on by an unbalanced force. Well, the second law said if there is an unbalanced force, they call it total force here, then it will change its velocity. Wait a minute. What is a change of velocity? An acceleration. So therefore, the total force, or the net force, I like that term better, acting on a body is equal to the mass of the body, that's the inertia, times the acceleration of the body, that's its change of velocity. Okay? So that's why I said that car going at 70 miles per hour on cruise control, constant speed, level surface, straight line, not changing direction, the total force acting on it is zero because it's not accelerating. Now, the component forces, lots of them. The tires on the road, the wind against it, whatever. Those are the individual forces. Now, what's the shorthand for this? This is one of the most famous laws in all of physics. That's Newton's second law. Force equals mass times acceleration. That's what it says here. The total force, I like to call it the net force, acting on a body is equal to the mass times the acceleration. F equal ma. Okay? Now that's the total force, or the net force, acting on the body. M is mass of the object. There's its inertia. Acceleration is its change of velocity. All right, I think we've just gone over 2 minutes. Okay, but guess what? There'll be no extra charge for tonight's class, and we will just go from there. So next time when hopefully it'll be Dr. McBool will be here, tell him you're starting at the top of page 126, and that's, if I were teaching the course, we'd go over that, and then you do example 1. We all do example 1 together. You have your pencil and paper. I have it on the whiteboard here. We do the example 1. And then it's followed by example 2 and example 3. And then you have the problem set at the end of this section. And you can do any of those odd number problems. Now, we haven't gotten there yet. You don't have them now. That's how I used to teach the course. So that's completely up to him, how he wants to do that. But that's what I suggest you do, so you get to know and practice the stuff as we do it. We didn't get any examples done tonight, so there's really no homework except to continue reading in chapter 5. I would say probably read most of it, or if not all the chapter, at least from this point on. Any questions? All right, Now, I didn't go back and check just to see if hopefully nobody was waiting in the waiting room. They were not. So it looks like this is going to be a great class. I'm so sorry I won't be able to teach it. Um, this is one of the larger of these classes that we've had since we started. I'm glad y'all are here, but Dr. McBool I think will be very good. He seems like a very sharp character. Now, he is from Pakistan, so he has a slight accent, but I'm sure he's used to slowing down and repeating things for students. Just ask him. Don't don't sit there and not understand what he's saying. Ask him. He seems like a really nice guy. I'm pretty sure he is a U.S. citizen, so he's been here a while, but he does have the remnants of a Pakistani accent. It's a lot like me. I can't go to northern U.S. and they not know exactly where I'm from. And I don't think I'll ever lose it. Okay, my southern accent. So, same deal. All right, any questions? All right, well then pick up next time with with page 126. Now, by the way, Janaya, did you stay in the class? Could you hear me or can you speak? Is your microphone working? Last time I checked, it didn't even indicate you had a microphone. Maybe she just gave up. Yeah, I don't see her here. All right. So it looks like, oh, some people are already leaving. So I'll go on and end the session. Good class. I talked too much, but after this, it's going to be mostly physics. He may have some things to correct about the syllabus and that kind of stuff, but other than that, I bet you it's going to be physics from here on out. Fun stuff, people. Fun stuff. All right. Thank you. All right. All right. Thank you so much. All right. You too. Bye-bye. I'm going to stop sharing. I'm sick and tired of sharing. And then I'm going to end the meeting for all of us. Bye-bye.